So let me take you guys to the computer to also show you what I've been kind of designing with the 3D files for it itself. And then I can also show you what we will do with the marketing to kind of do some community building. But I'm gonna just show you guys in a second. No worry. So now we're behind the computer. This is the 3D file for the frame itself, actually. So here you can also see like how I kind of made these 3D printed inserts and stuff. So that's all based on this computer file. But what I've been recently working on today was actually the mount here for the rear motors, for the electrical motors. So that is basically that we could have these two units. So this is the first one that we have two of them like right next to each other, and then this will then attach to the left wheel, and then the other one will attach to the right wheel. But then we basically have like a configuration where the brace for the electrical motors is also helping to support the frame, you know. So all of that is kind of becoming a torsional rigidity piece that also keeps some of the frame together and everything. So that is just basically how I also make sure that the alignment of the frame is proper, so that the actual chassis brake pieces where the wheels are attached to are also right, narrow, straight, parallel to each other. Because if there's like any type of a slight degree of angle lift where it shouldn't be, then you will feel that in the steering response. So as soon as you align the wheel, then it will kind of steer while it's not steering. So just a bunch of car technical suspension alignment stuff, but that is basically what I've been working on. And also this is the yellow component that you saw in the video earlier already. So on here on the bottom section of it, I will actually attach the rails. Damn, I can't talk. I will actually attach the rails where the your foot pedal box will be attached to. So you will have like your electrical gas pedal, and then also your electrical gas pedal doesn't sound right. Your power pedal and your brake pedal right there. And then here on the bottom we have another structural member that will also uphold the steering rack and everything. So that is what still needs to be done. This is the extra modification that I made for the steering rack, that I can actually also attach the another ball joint that I have to kind of, let me actually get that part. 3 parts actually that I could show you guys some stuff with. So this right here is the brake caliper. So this will sit with these two components that need to attach right here in the screen right here to the wheel joint, because then they will actually have the ability to stay stable on the wheel carrier. But then as soon as you press the brakes, then it will squeeze the brake disc and maintain its position. But this will need to be extremely strong while it is 3D printed to actually uphold it within its position while the brake forces are actually going through it, trying to drag it up with the rotation of the wheel. So that is something that I do need to pay attention to still. But you know, hopefully I'm gonna just make sure that this car runs up to maybe like 20 kilometers an hour. And then from that point forward, I will have a lot of these components just CNC milled out of aluminum to make sure that it is actually strong enough to do it, you know, because I don't fully trust everything the way that it is sitting right here, but we're gonna get there. So it's still, you know, gonna be like a driving car. This right here is the battery box. So in here I have the 4 battery units, but let me also get a real one. Let's rewind a little bit. So also for the component that I will need to be fitting here, that is actually this ball joint right here. So this will be attached to the suspension upright, and then it's able to actually push and pull on it to make sure that the angle changes so that you're actually steering. And this is what it actually looks like in operation. It's a little bit tough to kind of get it loose initially, but then there you go. As soon as she kind of moves, then it becomes a little bit easier. So this can, as like a ball joint configuration, is just like your shoulder in a way, where it can move in all different angles without having like any limitations to it. So that is what this component does, and that will still need to fit in there. And then here I kind of made the battery box. So let me also grab a battery that you could see the shape and the size of it. So it's a 12 volt 12 amp hour battery, and we have actually 8 of these in the car. So we're gonna mount 4 of them parallel to each other to make a 48-volt 12 amp hour system, and that will drive one of these motors. And then we will have another system of 4 motors that will be powering the different motor, the right motor. So let's say that this was for the left side of the car. So that way we actually have 2 individual battery systems for each motor on the side of the car. And also with the way that we're actually going to manage the power to the rear with a differential, or actually like creating an effect like a differential, is basically that we have the throttle sitting right here. And that is just a signal, the rotational sensor on the throttle that sends a signal to the battery packs that you're now actually like requiring to send electricity to the motor. It's late, I'm sorry. So as soon as but we also need to create a differential between the power that goes to the left wheel and the right wheel while we're steering, because we don't want to have a scenario where the wheels want to rotate at the exact same speed while you're turning into a corner. So then we need to take power away from the inside tire. So let's say you're turning left, then you actually need to take away power from the inside left tire to make sure that you can actually over-rotate the right, all that type of stuff. So what we need to do is actually mount 2 rotating sensors, one that is only taking positive measures to the right and one that's taking positive measures to the left. And then also attach that to the throttle to make sure that as soon as you're having like a 15-degree rotational input on your steering wheel, that there's like a 5% power split between the left and the right wheel, if that makes sense. But we can also put that on a toggle to make sure that we can kind of calibrate that for different driving modes or something. But then we can even add a drift mode with that function, or torque factoring in a way, to make it very rudimentary in a simple fashion, but still make it functioning to give the car the correct grip in different scenarios that it needs. That sounds very fun to actually begin to test that out in the recent weeks coming. That we can actually have some test drives to play with that system and figure out what would be the right percentage for the drift mode and what would be the best percentage for the actual grip mode. So those type of things, you know. So that is that's getting very fun indeed. These are the battery packs themselves, like I said, but we also need a place in the car to actually maintain them and also keep them cool. So what I designed is actually this box right here that will be attached to the frame right at the bottom of the car, because these batteries individually weigh about, I think it was like 4 kilos a piece. I think it was 4 kilos a piece. So we have 4 of them aside, which makes like 16 kilos on both sides of the car. So we also want to keep that very low and centered to the car, especially with your own driver, how do you call it? Center of gravity of the driver being also right here. So this will be like the heaviest part of the whole car assembly, basically. So that is why we also wanted to maintain the batteries in that position. And then in this box here, I also don't think that the batteries will need like a tremendous amount of cooling, but I did want to make something to where it would just have like a continuous air circulation in it. So even though it's not like a radiator or liquid cooled or anything, we just maintain like a proper airflow over all of the batteries. So we have like a air intake that will be placed within the wheel well right here. And then we can place like a fan on the exit right here, and then we have like continuous airflow going through this battery box. So right here we can hide the components. These will be the 4 individual batteries. They're spaced out a little bit between them to make sure that they don't like contact with each other, interfere, and then we need to also still do some of the wiring. So then this throttle is basically a rotating sensor that as soon as you kind of give it some input, then it will send a signal through this cable, through the computer control unit, through the throttle input cable that I just showed you. So we need to connect those up. That there is a certain percentage of power required that the driver kind of requests from the system, basically. And then the computer control unit here will have these 2 wires. These are kind of leading through the battery. So those are also the red and black connecting dots that you can see right here. And then we have these 3 different blue, yellow, and green colored wires that are then connected up to the battery. and then we then have those matching colors and everything. And then as soon as that signal gets sent through from the throttle, then the computer knows how much power from the battery it actually needs to send through the motor to kind of get that done, you know. But then on the throttle, before we actually send the signal on how much power we need from the electrical system, we're going to place one more sensor that is actually on the steering rotating on the we're going to place one more rotating sensor on the steering rod, that as soon as you're putting some rotation within the steering wheel, that we can also wrap some power of the inside corner that we need to wrap power from, whether you're steering left or right, you know. So the battery box I showed you already, but then these computer control units will also be mounted to the frame in this position. Maybe I should show it here in this position. And then we were able to actually loop up all the wiring and make like a nice harness for it that flows down the floor, the chassis too. So that is basically also the electrical system still left. And then I'm gonna take you guys back to the computer to actually show you some other stuff that I kind of want to highlight within the building of this whole project, you know. So here we are back in the office. Let me actually also pull up the body panels for the car, because I just kind of want to show like an overview on what it kind of takes to actually be able to build and design all of this, and just the whole process that it took me to kind of get to this stage, you know. So basically this is damn it is 3:11 in the morning, by the way. Basically this is now the car in its completion. There's still like some parts left or right that didn't mirror over, but this is damn near like the complete car. I can also like showcase with evaluate what the mass property would be. So now it's kind of rebuilding. It's not like complete, not all of the components are in there, but as it stands, it is 163 kilos, but it still lacks some of the batteries and stuff that needs to be on the other side. So let's say the car by itself will be about 180 kilos. And then with another additional driver in the car, it will be about 250, 260, depending on the driver's weight, of course. But in total, with the electrical motors and the batteries that we have in there, we will actually have about 6 horsepower, 4 kilowatts of power. And we will also have like a 40, no, that was per motor, I think about like 80 newton meters of torque. So that's quite substantial. It will be enough to actually make the car like accelerate from 0 to 120 kilometers an hour. I won't have like a time on how fast it will go, but it will have like a max speed of about 120. I don't trust the car with the 3D components to be able to do that. I won't drive it at that speed at this stage with the 3D printed components. But that is kind of like what we're looking at with the potential performance that we could get from the electrical system already. And there's also some fun gear drive things that I'm working on that could potentially also have some effect on it. And then we could maintain also fast acceleration at lower speed, but then have some high speed, top speed on the car as well. So that is that. And also, as you can see, the center of mass is pretty low, but also with the driver in there, it's going to be, I think, even lower, because then your ass will kind of become the center of gravity in a way. That sounds quite funny. But that is basically just what we have here with the car. But what I wanted to hint at is basically the journey it kind of takes to develop such a thing, you know, because it all started with the frame, of course, but I will basically hide some of these components to be able to highlight it. How I designed the car was basically from the seat out. So I made the seat first because I was in when I designed it in 2019. I was in product design college, and I had a class called product ergonomics, basically, and that is ergonomics is the teaching of how to design objects for human sizes. So if my shoulder width is these like dimensions, then I need to make a chair that fits my shoulders, you know. So that is basically what product ergonomics entails. And from that point forward, I started to design my objects that I made from a human perspective. Like I needed to make it for people. So the seat was the first thing I designed, and then the steering wheel came afterward. But with that, I made basically the seat, and then I placed 4 wheels around it. to basically make like the most compact way that I could actually fit these four wheels. And then I built the frame to kind of suit those dimensions, you know. So I wanted to have the pieces where the wheels are as narrow as possible in the frame, so that the suspension arms themselves could be as long as possible. The longer suspension arms you have, the more moment and force you can put through the spring, so that would become like optimal for the suspension. So that is basically where this whole kind of thin at the top, going out wide in the center, and then going back thin again for the rear of the car. Basically, that is where that whole shape comes from. So that is some kind of structural engineering that needs to be done. So that is basically where the process would start, is structural engineering. The second part would be the mechanical engineering, so the suspension and all of that type of stuff. The third part would then be the ergonomics and the actual design part, basically, of it. And then you actually also need to go for a car design, because you need to then also make like the body panels for it. So that is what we can show right here. And then for the body panels, you also need to make sure that not only do they look good, but they also need to be functioning throughout the aerodynamic profile of the car. So I've been doing a lot of CFD simulations to make sure that the flow of the air was actually the best I could make it. So that is why also these creases are on the car, to make sure that the release of the airflow is pretty smooth. Of course, this angle is a little bit too steep within there, so I still will make some aftermarket components to kind of aid the aerodynamic design. But basically the whole premise was to make sure that the all of the surface area that was standing upright and had like a large surface area to it, so all of these panels basically in the back, that we minimize that that surface area as low as possible, so that the vacuum that the car is pulling behind it would be minimized in a way. So that was on the rear. Here in the center section, I also wanted to make sure that the hood and everything guided the air more towards the sides of the car, instead of having to flow over the hood. So it just follows a shorter path to the rear. I've been trying to kind of explain the aerodynamics of the car, but I noticed that I'm getting too tired to actually comprehend these sentences, so I'm gonna just keep it as short as possible. I basically made the seat and the frame and the wheels and everything, and then I shrink wrap most of the body around it to make sure that it is minimum in its frontal area, and also that it doesn't like necessarily produce downforce, but also eliminate as much lift as possible. The car will be going like at tremendous top speed that it will actually like produce downforce, but I would like to kind of showcase the possibilities of a model like this, you know. Like that is also some part of the purpose of this car, is that I just showcase all of the talents that I have, to put it in one product that people could really say like, okay, you kind of know your shit, you know, you kind of know what you're talking about if you're able to build this. So that is kind of what I would also wanted to showcase, that I do have some, not academic, but some CFD knowledge on how to kind of optimize these profiles for aerodynamic flow, at least within SolidWorks, within the wind tunnel simulations that they have in here. You know, I don't have like real wind tunnel experience, but long story short, I was able to kind of combine the design with mechanical engineering, structural engineering, car design, aerodynamic profiling, actually like putting it the production manager in a way, is in a sense too, actually being responsible myself for assembling everything. The product lead actually coming up with the whole idea. So I've been able to kind of combine a whole bunch of different jobs that would actually be fit by different individuals within an automotive regular business. And I was able to kind of combine all of those things into one individual in a way, through my talents with 3D design. And that has made it also pretty cheap for me to actually build this car. You know, I didn't have to pay for a lot of these engineers or software developers or and you know, all of that. So I was able to kind of keep it low cost and also just efficient for myself without having to communicate back and forth between engineers and designers. I could design things with multiple thoughts in mind, you know, and kind of take things into consideration before I actually made it. So yeah, I'm gonna now have to edit this video and condense it so it doesn't become too long of a whole story and everything. But there's one final thing that I do want to showcase before I get out of here. Let's close all of these. Yeah. And that is actually what I've been building in Unreal Engine, because with this all car building process, I also want us to be able to build a community for the owners of the cars, and also have like some type of a marketing device where I could showcase the car in different colors and build like configurators and all of that, you know. So with the 3D designs that I already made within SolidWorks, I was able to export those to Unreal Engine. And within Unreal Engine, I have the full gamification ability to kind of turn those 3D designs into whatever I want to, you know. So I can take those cars and play around them with, and make them actually drivable, to make sure that I can play around my video game environment with it. And also because I'm doing this from like a real intent to kind of push my neighborhood onto the next wave of development and all of those type of things, I also really want to ensure that I inspire them. And that is kind of something that I could do more so within the digital space than in reality, because I've just more freedom that I don't really need the budgets to do stuff, you know. So that is kind of what this world is intended to be. That is like an inspirational representation of my actual neighborhood. So I'm making like a digital twin, but with some added freedom on how I kind of wanted to make it look in the future. So I dragged some 3D files out of 3D Amsterdam, which is like a website where you can download like schematics for the neighborhood and stuff. And I then basically am remodeling it now through Google Earth and through pictures and photos and all of that, you know. So this is basically the file from 3D Amsterdam, and I'm slowly then rebuilding it to make sure that it is just in an realistic feel, you know, so that I don't have these ugly lines and stuff like that running through it. So now you might probably not recognize it fully yet as like as the real bicycle lane that this is in my neighborhood, but for the people that live here, I think it might become somewhat familiar while I'm at the other road. But with that being said, there's also like a video game in production where you can actually take the micro car and race it against people in the neighborhood, you know, and then also drive it around and listen to music from the neighborhood. And I'm gonna turn it into like a whole cultural happening to make sure that it is actually like a fun to play game without it just being like a promotional tool, you know. So there will be real storytelling within this and all of that. Like I'm getting crazy excited to actually see that these things are coming to fruition, you know. We're really getting close, and I'm building also like a team around me to be able to actually do all of this stuff, so that I'm not just by myself doing it, you know. I actually have like an office here to build this stuff out. So you know, we're stepping up our level of professionalism and really getting there to a point where, you know, this is becoming reality, and it's very inspiring and motivating. It will keep me going. But at the same time, like also on this journey, like I just I've been recognizing like all of the struggles that it comes with, you know. So it really comes with true sacrifice. I've been noticing that there's people that are gravitating towards me, but also people that I'm kind of pushing away within this process, and some of the closest people to me, you know. And that is very hurtful, to be honest with you. I wish that I had some more support from those people close by me, but I also recognize that I've been extremely selfish in this whole process, you know. I've been working at these type of late hours. I've not really like tried to communicate with a whole lot of family or people that I love in the process, and it just yeah, chasing your dreams and sacrificing time away from people it gets there, you know. And it also at the same time is somewhat of a signal that I'm on the right path, and I'm really trying to accomplish something and make like a difference for myself in my life. But I also recognize that that comes with some different struggles and turmoils. Yes, I live a comfortable lifestyle. I get to pay my bills by doing something that I love every day. I don't work for nobody. I don't have like a alarm clock in the morning, evening, but that the benefits that come with the lifestyle that I live also at the same time have some turmoil and some downfalls along the way too. And those sacrifices are kind of hard to deal with. I've spent it haven't seen like some family members in months, literally. But at the same time, I also know that there's a bigger purpose behind it, and I have to be selfish in a way, but at the same time, I'm not doing this for me at this point. I feel like I've already reached a level in my life where I get to be comfortable and not have to look over my shoulder all day for how I get to, put some bread on the table. But I also want to be able to provide that opportunity for a lot of other people. And through the things that I'm working on, I feel like I really have the opportunity to do so for hundreds of people even. But in order to accomplish that, and I just need some more time to be able to figure some stuff out, So yeah, I don't know. It's a beautiful process, but at the same time, it needs to be built for it because it gets stressful. It really gets fucking stressful. I've been hacked too. Like I've people in my family have been diagnosed with cancer. Shit like that is going on all over the time, and I'm just trying to keep my head high and make sure that my dream becomes fruition, and that the sacrifices that I make actually also get rewarded at the end. But it's life is beautiful, bro. Like I wouldn't trade it for the world. At the same time, this is so to really truly walk in your purpose, and to also be able to look down your family tree and see that your whole life kind of leads up to this moment is special. It's really special. Like I don't feel like people around me get to reach these levels of satisfaction that I feel at the end of the day when I busted my ass, but feel like I really accomplished something. So I want to trade it for the world, and I'm willing to sacrifice my life for this shit. Like, and it's scary sometimes, but I also need to recognize what I'm worth, and that my life is also, with the responsibility that I carry on creating like a better life for these other people, then my personal life also becomes more valuable, that I need to be able to maintain my health and be able to produce at this level for months to come, and not just this period. So I'm starting to become very conscious about not just who I am, but kind of, yeah, in different facets, just not just my purpose, but also on my personal. And I don't know, life is just getting crazy, and I'm just getting a lot of information all at the same time. But I just felt like maybe I just needed this moment to kind of vent about it. I don't know. If you're still watching, thank you. I will be doing this more often. I also have some people helping me now with my social media, and so there's a lot more coming. Please stay tuned to that. And yeah, I'm just working on my dream every single day. So follow me on this journey. I'm Shaquille Veldboom. This has been Veldboom Studios. I need to get some sleep. Thank you for watching. Peace.